Hi everyone, in this tutorial I will show you how to encrypt and password protect a data storage device with VeraCrypt. Please note that in the tutorial I am using a Linux distribution, Ubuntu Jammy Jellyfish, to encrypt and password protect the device. If you are using Windows 11, in the description I included a tutorial for utilizing VeraCrypt with Windows 11. First, let us review VeraCrypt. VeraCrypt is a free and open source application used for establishing and maintaining on-the-fly encrypted volumes. On-the-fly encryption, also known as transparent encryption or real-time encryption, means that the data is automatically encrypted right before it is saved and decrypted right after it is loaded, without any user intervention. VeraCrypt never saves decrypted data to disk, it only stores data temporarily in memory. Even when the volume is mounted, data stored in the volume is still encrypted. When you turn off your machine, the volume will unmount and files will stay encrypted. In the tutorial, I will show you how to install VeraCrypt, encrypt and password protect a data storage device, access files on the protected drive, and how you can remove the VeraCrypt encryption from a drive. Within the tutorial, I will walk through how to use the VeraCrypt CLI and the VeraCrypt GUI. I put timestamps in if you want to skip to the part that is relevant to you. Within the description, I linked a shell script for all the bash commands that I run within the tutorial. Let us get into the installation. Since I am using Ubuntu Jammy Jellyfish, I am going to use wget to download the Debian package from the VeraCrypt website. I am going to use wget again to download the PGP signature for the Debian package to make sure that the file wasn't tampered with. I am going to use the curl command to download VeraCrypt's public key and import it into my keyring so I can verify the signatures. If we zoom in, we can see that we have the key ID here from our curl command. We can type in part of the key into GPG to get the full fingerprint of the key. Inputting part of the key into the GPG fingerprint, we receive the full hash. I am going to compare the full hash up against the hash on the GPG website, and we can see that the two match. Finally, I will verify the authenticity of the Debian package from VeraCrypt using the signature file in GPG. From the output below, we can see the date and time the signature was made, and that it was created using the RSA key, which we verified against VeraCrypt's official website. The signature is identified as being from the VeraCrypt team. The warning appears because GPG has not been explicitly told to trust this key, not because the signature is invalid. Overall, this output confirms the integrity of the Debian package and shows that it was signed by the holder of the VeraCrypt private key. Next, I will run chmod a+r on the Debian package. This adds read permission to the deb file. I'll run sudo apt update once more just to refresh the index. And I will run sudo apt install to install VeraCrypt. To clean things up, I am going to use the rm command to delete the Debian package and the signature in my current working directory. I will run VeraCrypt --version to check our VeraCrypt version, and we can see that we have it successfully installed, and as of the recording, we have the newest version of VeraCrypt 1.26.24. Now that VeraCrypt is installed, I am going to plug my USB flash drive into my computer. I have a SanDisk 64GB flash drive here. Let's go back to the terminal. In this portion of the video, I will show you how to use the VeraCrypt CLI or command line interface to encrypt and password protect a data storage device. Now that my USB flash drive is plugged in, I am going to run the command lsblk, which lists information about block devices and their partitions on the system. Here we have our USB showing. We can see that the USB is labeled as a disk. We can see the USB is also mounted on Media Adrian. In my GUI, I am going to click on the USB icon, and we can see that it is currently empty. A warning before we proceed with encrypting the flash drive. If you are encrypting a device, be sure to back up the data to another device. Creating the encrypted volume reformats the drive, and all existing data will be lost and unrecoverable. Before we can encrypt our device, we need to unmount it. I will run sudo umount to do this. I will use mkdir to create a directory where VeraCrypt can attach our volume once it is decrypted. Now let us encrypt the flash drive. Let us review the code. I will call sudo to run the command with root privileges. The -t flag lets us run the command in text mode. The -c flag creates a volume on the entire device SDB, which is the flash drive. I will set the volume type as normal, which creates a standard volume. The other option is to create a hidden volume, which is an encrypted container nested inside another VeraCrypt volume. I am going to set the encryption algorithm as AES, which is for the AES 256 cipher. The other encryption options include Serpent, Twofish, Serpent Twofish, AES, and AES Twofish. For the file system volume, I will format it as FAT32. If you need to work with larger files, then you can format the volume as exFAT. For the personal iterations multiplier, or PIM, I will set it as 0. PIM controls how many hash iterations are used when deriving the key. The larger the PIM number, the harder it is to run a brute force attack. However, a larger number will also slow the time it takes for your drive to mount to your machine. Under the -p flag, we will set the password for the VeraCrypt volume. I will run the command in non-interactive mode, which will stop VeraCrypt from prompting me with additional questions. I will also use the quick flag, which skips the full random wipe and only writes the header and file system. If you want the full random wipe, then drop this flag. However, this can take well over an hour to run. Once the command stops running, you will receive a notification that the VeraCrypt volume was created successfully. Since we typed out the password and it is saved in the terminal's history, I am going to clear the history by running history-c. If we check the history, we can see that it was cleared, so no one else can see what our password was for the encrypted volume. Let us mount the flash drive. I will run the command in text mode. I will mount the flash drive SDB onto the directory we created earlier, USB_secure. I need to specify that the PIM value is 0. I am prompted for the password for the encrypted USB. I will input it now. I do not have a key file, so I will press enter, and it asks me if I have a hidden volume. I do not, so I will press N. Now that we have access into the encrypted USB, I am going to create a simple text file. I am going to input the statement hello world into the text file. If I use the ls command to list everything in our mounted directory, we can see that we have the file there. Now I am going to unmount our flash drive from our directory. I will call on VeraCrypt and -u, which will unmount the drive. We can check that the flash drive is unmounted by listing the USB secure contents. We can see that the directory is empty now that our flash drive is unmounted, and we cannot access that text file we created. To double check, I am going to run ls-al, which will also show hidden files, and we could see that the text file is not there. And again, this is because we dismounted our flash drive. To remove the VeraCrypt volume, which is the encryption and password protection, we need to delete the headers and any file system signatures, then create a new unencrypted file system in its place. Similar to when we were encrypting our device, when we decrypt and reformat our device, the data on it will be lost. Be sure to move any data off of your encrypted device before you decrypt it and reformat it. Before we wipe the device and reformat it, ensure that your device is unmounted. We know that the device is unmounted because we ran the command earlier. I am going to run sudo wipefs and specify all to erase everything on the dev SDB device. This erases all existing file system and signature metadata, including VeraCrypt. Next, I will run mkfs.vfat on the USB, which is going to create a new FAT32 file system on the device. This will overwrite the old metadata. Using my GUI, I am going to click on the little icon that stands for the flash drive, and we can see that the folder is empty. This shows that we were able to unencrypt and reformat the drive, and now we have a regular unencrypted flash drive. In this portion of the video, I am going to show you how to use the VeraCrypt Graphical User Interface, or GUI, in order to encrypt and password protect a data storage device. On the left, I have the icon for my flash drive. A warning before we proceed with encrypting the flash drive. If you are encrypting a device, be sure to back up the data to another device. Creating the encrypted volume reformats the drive, and all existing data will be lost and unrecoverable. We can see that the current flash drive is empty, so we do not need to move anything off of it. I am going to bring up the VeraCrypt GUI. I will click on the Show Applications in the bottom left, and we have the VeraCrypt GUI. Through the VeraCrypt GUI, we can create an encrypted volume on our flash drive, and we can mount any VeraCrypt encrypted drives. Now I am going to select the device that I want to encrypt with VeraCrypt. I am going to toggle the Select Device button. Here I have a list of devices and partitions. You can either encrypt the device itself, or you can select a partition to encrypt. I am going to select the partition for the USB drive. Now that we have the partition selected, we can create the encrypted volume. For the VeraCrypt volume encryption, we have two options. The first option is to create an encrypted file container. With a container, you can still keep non-encrypted files on the same drive. VeraCrypt stores the encrypted volume in a single file. By default, VeraCrypt suggests giving this file a .hc extension name. You can copy, email, or sync this file just like any other. No repartitioning or reformatting of the device is required. The drawback is that the container file is visible to anyone who can browse the drive, so they can infer that some encrypted data exists, although you can rename the file to disguise it. The container's capacity is fixed at creation. If you need additional space, you must resize the volume, or you can create a new, larger container. The second option places VeraCrypt directly on a whole drive or a specific partition instead of inside a file. This gives an all-or-nothing privacy. After creation, the device looks like random data, so nothing on it is readable without the password. You do not have to size the encrypted file system because it automatically spans the entire device or partition. The drawback is that the process reformats the target partition or drive, erasing everything that was on there, so you must back up and copy data to another device. If you encrypt the whole device, the drive cannot also hold unencrypted files unless you create additional separate partitions first. Mounting typically requires administrator rights, and backing up the volume means cloning the whole partition or copying files after mounting. I'm going to encrypt the whole partition. Next, I need to choose the volume type. A standard VeraCrypt volume is a single encrypted container, drive, or in this case partition that mounts after inputting the password. Everything inside is unreadable without that password. It provides strong confidentiality. A hidden VeraCrypt volume nests a second secret volume inside the free space of a standard volume, and is unlocked with a different password. Because the hidden header and data look like random noise, it is very difficult to discern that the hidden volume exists. I am going to go with the standard volume. We need to select the device. I am going to select the partition for the USB flash drive. We receive a warning about encrypting a whole partition or device, but we know that we do not have anything currently on our USB flash drive, so we are good to encrypt it. VeraCrypt prompts you to input the password for the administrator for the host machine. We need to choose the encryption algorithm that we will encrypt the partition with. We have options such as AES, Serpent, and Twofish. I am going to go with the default AES 256 encryption algorithm. The hashing algorithm is used for key derivation and for the header integrity check to ensure the volume has not been tampered with. I am going to select the SHA-512 algorithm. Next, we need to set the password for the encrypted volume. You can also opt to use PIM. PIM controls how many hash iterations are used when deriving the key. The larger the PIM number, the harder it is to run a brute force attack. However, a larger number will also slow the time it takes for your drive to mount to your machine. If you do not use PIM, there is still a default value of 0 that is set for the PIM value. I will leave the PIM as is, meaning the default value is 0. A key file is an optional file that adds an extra layer of security by being required alongside your password to mount a volume. In this case, I will leave it blank, meaning that we will not use a key file. If you are working with large file sizes, then you can click yes here. I am going to leave it as no. We now have to format our volume. We have a few different options for the file system. We have FAT, which is best for cross-platform compatibility, meaning that you can use the drive with Windows, Mac OS, or Linux. We have a few Linux-only based file systems. We have NTFS, which works best with Windows systems and can support large file sizes. Finally, we have exFAT, which is cross-platform and supports large file sizes. I am going to go with the FAT file system. I am also going to quick format the volume. We get a warning from VeraCrypt that you should only use quick format if your device contains no sensitive data and you do not need plausible deniability or the device or partition has already been fully encrypted. I will just use quick format for the partition since we are going through the tutorial. If you do fully encrypt your device or partition, please note that it can take an hour or a few hours to fully encrypt the device or partition. Here we have our final step. The random pool is a pool of random bytes that VeraCrypt builds from your mouse movements plus the operating system's own random number generator and, on some systems, keystroke timing. Checking display pool content displays those bytes in hexadecimal format. The randomness collected from mouse movements bar fills as you move your mouse. After you click format, the lower field becomes active, showing how many megabytes have been written, the throughput, and the remaining time. Because quick format was selected earlier, VeraCrypt writes only the volume header and the new file system metadata, skipping the full random wipe, so the entire operation typically completes in just a few seconds. We receive one last warning to move any data off the partition or device. VeraCrypt is running, and we can see that we have successfully created our VeraCrypt volume. I am going to exit the volume creation, and I am now going to mount our newly created VeraCrypt volume. We already have our partition selected. I am going to mount it. I need to enter the password for the encrypted volume. I will press OK, and we can see that the volume is now mounted. I can use the Files application to open the encrypted volume, and we can see that it is currently empty. I'm going to create a simple text file that says Hello World within the text file. We can see that we were able to successfully create the text file within our encrypted volume. I will unmount the volume by clicking the Unmount button, and we can see that the volume is no longer displaying in the VeraCrypt wizard. To remove the VeraCrypt volume, which is the encryption and password protection, we need to delete the headers and any file system signatures, then create a new unencrypted file system in its place. Similar to when we were encrypting our device, when we decrypt and reformat our device, the data on it will be lost. Be sure to move any data off of your encrypted device before you decrypt it and reformat it. Before we wipe the device and reformat it, ensure that your device is unmounted. We know that the device is unmounted because we ran the command earlier. I am going to use the disks application to reformat our disk drive, specifically the partition which has our volume. I am going to select the flash drive. I am going to select the 3-button icon and select Format Disk. I will leave the default settings and I will click Format. We receive a warning that any data will be overwritten. Again, be sure to take any data off of your encrypted drive before reformatting it. I will toggle the plus sign. We will create the partition. I will leave the default values. I am going to name the volume My USB, and I am going to format it as a FAT file system. I will press create. We have successfully reformatted and unencrypted the drive. If I bring up the Files application, we can see that we have our USB. We no longer need a password to access it. Thanks everyone for watching. I hope that this video was helpful. If you want to learn more about VeraCrypt or on-the-fly encryption, I included a link to the VeraCrypt documentation site. If you found this video helpful, feel free to like and subscribe. You can also connect with me on LinkedIn, X, GitHub, Medium, and Odyssey. I also have a podcast called The Aspiring STEM Geek, which you can check out on YouTube, Spotify, Apple Podcasts, Audible, and iHeartRadio. Thanks again for watching and happy coding.